Hi students, welcome to our video classes. In the previous class we have learnt about latent heat. Already I told you, latent means hidden. Why it is called as hidden? That means during the phase change, that means melting or boiling, even we supply heat, there is no rise in temperature. That means the reading in the thermometer is not increased. That means that is not observed. That's why it is called as latent heat. This latent heat is of two types, that is latent heat of fusion and latent heat of vaporization. Let us learn about latent heat of fusion. What is this latent heat of fusion? Observe this curve. That means when we heat a solid substance like ice is taken in a beaker and it is heated. At first the temperature of ice is very low, that means less than 0 degrees Celsius, minus 25 degrees Celsius, like that. When we heat this ice and slowly on a low flame, the temperature increases from minus to minus 25 to minus 24, minus 20, minus 1 to 0. Whenever the temperature reaches to 0, we observe ice and water in the beaker. That means the ice starts melting at this temperature. At which temperature? 0 degrees Celsius. That's why this 0 degrees Celsius is the melting point of ice. During this melting of ice, that means solid to liquid, even we supply heat, there is no rise in temperature. That means this heat is utilized to convert the solid into liquid. How it is utilized? When that heat is supplied, the temperature rises, and that means the kinetic energy of the particles increases, and a stage is reached. Okay, at that stage, this heat, which is the energy which is supplied, this breaks the attraction between the particles. Whenever the attraction is broken, the particles move further and the solid is converted into liquid. That means at this 0 degrees Celsius, say melting point of ice, this melting point of ice at this stage, that means during melting of ice, means at 0 degrees Celsius, the heat which is supplied is used for somewhat. How it is utilized? At first the heat energy which is supplied, that increases the kinetic energy of the particles. That kinetic energy increases, a stage is reached. At the stage means at 0 degrees Celsius, that energy is broken the attraction between the particles. Okay, that means the energy is sufficient to broke the attraction between the solid particles. Okay, that's like that, the attraction is broken between the solid particles. Whenever this attraction is broken, the solid particles move apart. That means solid is converted into liquid. Like that, the phase changes happened at this melting point without a rise in its temperature. Okay, like that, the heat which is supplied to change the state of matter, which matter? Solid matter to liquid matter, without a rise in its temperature, simply that is called as latent heat of fusion. That is what? Latent heat of fusion. Okay, why in the latent heat of fusion means, in this latent heat of fusion, solid is converted into liquid. That means ice is converted into water without rise in its temperature. Okay, to change the phase, some heat energy is required. That heat energy which is required to change the substance from solid phase to liquid phase without rising its temperature, that means at its melting point, that is called as latent heat of fusion. Observe this curve, that means graph, temperature versus heat graph. In this temperature versus heat graph, okay, below 0 degrees Celsius heating of ice is done. At 0 degrees Celsius, heat is used to fuse ice to water. That heat energy which is used at this constant temperature to fuse ice to water, that is simply latent heat of fusion. Latent heat of fusion of ice. Here, how much energy is required to convert the solid into liquid, say ice to water? Okay, that means while defining this, how much ice is taken? That means unit mass of substance. Here unit mass of substance means when 1 kilogram of ice is taken, to convert that 1 kilogram of ice into water at 0 degrees Celsius, some heat energy is required. that heat energy required to change the solid, that means 1 kilogram of ice into water, is 3.34 into 10 to the power of 5 joules per kilogram. Simply it is 335 kilocalorie per kilogram. This is the latent heat of fusion of ice. Then, is the latent heat of fusion of all substances is the same? No, it is different for different substances. Why this latent heat of fusion is different for different substances? Already I told you. The attraction between the particles of all solid matter is not same. In some cases it is low and in some cases it is high. For example, if we take a solid like cesium, if that cesium is placed in our palm, it melts at our body temperature. That means its melting point is low. Okay, like to convert that cesium in solid cesium into liquid cesium, the heat energy required at its melting, that is lower, that is different to the latent heat of fusion of ice. And in the same manner, if we take iron, its melting point is high, means the attraction between the particles of that solid matter iron is very high, then its latent heat of fusion is also very high. Okay, next about another topic, that is latent heat of vaporization. Already we have learnt what is vaporization. Simply, what is vaporization? The change of state from liquid to gas, that is called vaporization or boiling. Okay, at first from less than 0 degrees Celsius in the case of ice, less than 0 degrees Celsius to 0 degrees Celsius, ice is converted into water. On further heating, what is happened? The temperature, after all the ice is converted into water, the temperature rises from 0 to 10, 20, 30, 40, 90, 99 like that. And it reaches to 100 degrees Celsius on further heating. Whenever it reaches to 100 degrees Celsius, we observe formation of bubbles in the water. This formation of bubbles means what is happened? The liquid substance is changed into gaseous substance. That means water is changed into steam. Whenever the water starts changing into steam at 100 degrees Celsius, the temperature remains constant at 100 degrees Celsius even we supply heat. Okay, that means even we supply energy, there is no rise in the reading of the thermometer. Why there is no rise in the reading of the thermometer? Again here also, the heat energy which is supplied is used to break the attraction between the particles. That means the energy of the liquid particles increases and a stage is reached. At the stage, the energy, the kinetic energy of the particles overcomes the attraction between the particles, then automatically that attraction is broken. Okay, that means to break that attraction, again energy is required. That heat energy required to convert a liquid substance into gaseous substance without rise in its temperature. That means at its boiling point. That is called as latent heat of vaporization. Okay, that means here this heat is hidden. That's why it is called as latent heat. Okay, here the latent heat of when the water converts into steam at 100 degrees Celsius, okay, that water to convert into steam, some energy is required. That energy is 22.5 into 10 to the power of 5 joules per kilogram. That means if 1 kilogram of water is taken, to convert that 1 kilogram of water into steam, some amount of energy is required, that is 225 kilojoules per kilogram, or 22.5 into 10 to the power of 5 joules per kilogram. It is the latent heat of vaporization of water. Okay, and this latent heat of vaporization of all substances is not same. For example, if we take acetone, okay, that acetone vaporizes at a room temperature. Acetone means nail polish. And sometimes, doctor, that spirit is applied while an injection is injected, when a needle is injected into our body. Okay, it evaporates at the body temperature. That means its boiling point is low. That's why its latent heat of vaporization is also low. Why attraction is low? Like that, this latent heat of vaporization is different for different substances. That means till now we have learnt about the phase conversion from solid to liquid, liquid to gas on heating, and liquid gas to liquid, and liquid to solid on cooling. But some substances like ammonium chloride, iodine, camphor, and anthracene, on heating these substances, these are in solid state. On heating these solid substances, that directly changes into vapors, gaseous state, with the absence of liquid state. Okay, but actually what is happened? Ice on heating changes into water, water on heating changes into gas. That means solid to liquid, liquid to gas. On cooling, gas to liquid, liquid to solid. But some substances like ammonium chloride are some substances, these substances on heating, solid substances on heating, directly it changes into gases with the absence of liquid. This process of changing a solid into vapors on heating with and cooling vapors changes into solid with the absence of liquid. That means here in this case, which phase is not observed? Liquid phase is not observed. This process is called as sublimation. Let us observe an activity to understand the concept of this sublimation. What is the activity? For that activity, check a china dish. In the china dish, take some ammonium chloride or iodine or camphor or naphthalene. What is available? That we have to take some amount of this substance in the china dish. Okay, and that is placed on a massive or tripod stand for heating, and a glass funnel is taken. Place the glass funnel on the china dish in inverted position as shown in the figure. Okay, and slowly heat it with a Bunsen burner on a low flame. Okay, while heating, observe one thing. Take a cotton plug, and at the nozzle open end of this glass funnel, this cotton plug is inserted. That means if any vapors are produced while heating, that vapors are trapped in it. For that, the cotton plug is fitted in the neck of the thistle funnel, opening end of the thistle funnel tightly, slowly heating on a low flame. Okay, after some time what you observed? We observed fumes, that means gaseous substances. Okay, but we didn't observe any liquid in this. How these gaseous substances are formed? On heating this solid ammonium chloride or iodine, that are changes into gaseous substance. We observed vapors. Okay, and that vapors are trapped inside the funnel. Why? It is enclosed. Okay, if any gap is found, take care by to close that gap. Okay, and after observing these fumes, turn off the flame and left aside. Left aside means what is happened? Cooling. After cooling, we didn't observe these vapors. Okay, that means a solid substance is sticked to the internal walls of this funnel. To observe this solid substance, take a glass rod and scratch the internal walls of the thistle funnel. Okay, we observe a residue, some solid substance. How it is formed? That means at first, on heating this solid substance, directly changes into gases, and on cooling these gases again changes into solid. That solid is formed on the internal walls of this funnel. In this case, we didn't observe the liquid phase. Okay, that's why this process is called as sublimation. Okay, in this, the solid substance which undergoes sublimation, that is said to be sublime. That means if ammonium chloride is taken, it undergoes sublimation. That ammonium chloride is said to be sublime. Okay, and the solid obtained by cooling the vapors, that is said to be sublimate. Here on cooling these ammonium chloride vapors, okay, solid ammonium chloride is formed, solid, that is sublimate. Okay, but observe, when all the substances doesn't undergo sublimation, only some substances like ammonium chloride, iodine, camphor, naphthalene, anthracene. This is about sublimation. Okay, next, effect of pressure on the state of matter. Okay, not only the temperature changes the state of matter, The pressure also changes the state of matter. Okay, how this pressure changes the state of matter? To understand this, take a vessel, long cylindrical shaped vessel with a piston. Okay, which type of piston? That is frictionless and leak proof piston. Frictionless and leak proof piston is taken as shown in the diagram. Okay, and take some gaseous substance, press the piston downwards. If you press the piston downwards means what is acted on it? Pressure is acted on the gaseous substance which is taken in the enclosed vessel. Okay, that means the pressure increases. Whenever the pressure increases, what is happening? The gaseous particles come closer. Okay, that means the arrangement of the particles is changed. Which are farther, that are come closer. Means what is happening here? Gaseous substance is changed into liquid substance. Okay, and further increasing the pressure, again the particles still come closer. Means again liquid substance is changed into solid substance. Okay, liquid is changed into solid substance. That means here in this case, on applying pressure, the state of matter is also changed. Okay, that means these liquids can be liquefied, gases can be liquefied by applying pressure and lowering temperature. That is clearly observed in a refrigerator. For example, in the deep freeze region, even if we didn't place any water, we observed ice in the deep freeze. How this ice is formed? That is due to water vapor in the air which is gaseous state that enters into the deep refrigerator. Okay, and in the refrigerator compressor is there that increases the pressure. Whenever this compressor increases the pressure, this gaseous water vapor is changed into liquid water and liquid is changed into solid ice. That means it is compressed. Like that, these gases can be liquefied by applying pressure and lowering temperature. Like that, there is an effect of temperature on the state of matter that is observed clearly in our daily life. Okay, for domestic cooking, what is used? LPG gas is used. Okay, LPG gas. LPG means liquefied petroleum gas. Okay, that means larger volume of gaseous substances that are filled in the cylinder. When that larger volume of that gases are filled in the pressure, that in the cylinder, the pressure is increased. Whenever the pressure increases, that gases gets condensed and changes into liquid state. That's why it is called as liquefied petroleum gas. Okay, and observe one thing. Take a carbon dioxide cylinder and take a bag made of canvas cloth. That mouth of the bag is inserted to the nozzle of this carbon dioxide cylinder and tied tightly. Okay, if you open the vessel cylinder, the carbon dioxide gas ejected into the canvas cloth bag with high pressure. Okay, that means the pressure is suddenly increased. The pressure is increased. And if you open the canvas after this, if you open the canvas cloth bag, we observed solid flakes of carbon dioxide. What is the solid flakes of carbon dioxide? That is solid form of carbon dioxide. That is the dry ice. That means on increasing the pressure on the solid carbon dioxide gas, it is condensed, converted into solid state. All this shows the effect of temperature on the state of matter. Okay, and if we open the canvas cloth bag, it is exposed to atmospheric pressure. That means its pressure decreases. Again, that converts into gas. Okay, and it mixes with the atmosphere. That means not only increasing the pressure, decreasing the pressure and raising the temperature can be the state of matter. Okay, that means increasing pressure and lowering temperature changes the state of matter, and decreasing pressure and raising the temperature also changes the state of matter. Okay, this is the effect of pressure on the state of matter. Next topics we will learn in next class. Okay, thank you.